The purpose of this video is to go through the 30 types of questions you will have on your final exam. The final exam will cover all the topics from module 1 to 4, and I designated them here by different colors. We start with simple equations and inequalities as absolute value and linear equation, and the definition of relations and functions, and go through of some of the main algebraic expressions. That's the polynomial, the rational expression, radical expression, and a special type of polynomial. That's the quadratic expression with degree 2. And with these expressions, we're going to deal with functions of each one of those, and also equations, solving equations with problem solving. Question 1, 2, and 3 are related with the content in module 1. That is compound inequality using the and, then compound inequality using the or, and how to solve those compound inequalities, and then to solve absolute value equation. You see that this is an equation with the equal sign, and it's absolute value because it has the 2 bars. Okay. When I have 2 inequality, I solve each one independently, and then I look at the end. The meaning of the end is the intersection of the solution set. So I just want what is common to both of them. And then I start here, negative 2x has to be less than negative 6. What is the value that x must be? So I have to solve for x. I'm going to divide both sides by negative 2 to make this positive 1. And when I do that, I have to remember that my inequality invert the sign, and now 3. So the first solution is that every x that is greater than 3 would make this statement a true statement. For example, if I get number 10, 10 times negative 2 is negative 10. Negative 10 is less than negative 6, okay? So you just come in your mind, try to see if your answer makes sense using a value that satisfies this, and plug in on your inequality to give you the certainty that you found the right thing. If you forgot to invert the sign, and you would get a number to plug in here, and you would see that something was off because you forgot to invert the sign. Second inequality, x minus 3 has to be less than 5. Here, my x is by itself, but it's subtracting 3. So I add the opposite of negative 3 on both sides to get rid of this term here. And now my x is less than 8. Okay, so I have 3 number lines here. I'm going to display each one of them and paying attention to put those numbers in order like in a number line. So if my 3 is here, I would put my 8 here because 8 is bigger, then it's on the right side. So on the first inequality, everything that is greater, not equal, just greater, then on top of 3 is open because the 3 is not included, but anything greater than. And here, any x that is less than 8, not equal, just less, then is open as well. And then anything that is less than 8 going to negative infinity. And now, like I said, the end, consider what is common. So I see what is on both number line. So the 3 is here, but it's not here, then it's open. 8 is here, but it's not here, then it's open. So graphically representing, this is the solution. Any number between 3 and 8 will satisfy both inequality. And then they ask you to write the solution. Then you have to read, keep reading how they want the solution. They want the solution in interval notation. And then you have to know that when it does not include, I use parentheses. And when does includes a number, I use brackets. And then space parentheses on both sides. So this even look an order pair. However, we are talking about interval notation, then I know how to read this as interval notation, not as order pair. So it's just like a normal language. When you see the word bear, can be a verb or can be an animal, depend of the context here as well. Okay, proceeding. Now I have two inequalities with an or. The or means not common thing, but everything that belongs to the solution of each one of them. One or the other, both solution sets is a union. So let's starting solving the inequality independently. -6, 4x minus 28 greater than and equal -8. Okay, so here I have a -2 multiplying x, so I have to divide by -2 on both sides to make the coefficient of x 1. Now x has to be greater or equal number 3. Invert the inequality because I divide by a negative number. Here, first I have to get rid of this term by adding its opposite, and I do on both sides. So this term disappears. Now I have 4x greater or equal the number 20. Now I'm going to divide 4 on both sides to get x by itself, and now x equal 5. Oh, greater or equal 5. Okay, number line. For the first one, I represented the 3 right here. The second one, a little bit to the right, is my 5. X is greater or equal. So if it is equal, the dot is closed on 3. And then anything that is greater. And then 5 also. 5 and greater. Now I have to do the union, everything that is here and everything that is here. So it means that I have to start here. And I keep going. Because this part here includes this one. And then so this is my final answer. And again, I have to write this as a interval notation. Now that is what I mentioned previously. When this number is included, and then if it is included, I put a bracket. And goes forever to infinity. I can use any number as big as anything bigger than 3. Then goes to infinity. And the infinity always, because it's never possible. So this is not a number, it's a representation of something that continues infinitely. I always find the next number, then always open. Now the number 3 is to solve an absolute value equation. Remember that absolute value is of a number. So inside of here, I have a number that is different based on the value of x. And it represents the distance of that number from 0 in a number line. So the distance is always positive. It doesn't matter if your number is on the left or the right. So if I have a 0 here, and here I have 3, and here I have -3, both have a distance of 3 units from 0. Then this is the reason that an absolute value, you always have two answers. One that is a negative number and the one that's a positive number, because they both are possible numbers that will lead to one answer that is the distance to 0. Okay, so it means that this number here must be equal this number. Or this number here is on the opposite side, so has the opposite value. And then you always break down your absolute value equation in two equations. One that carries the same value. So they must have the same value to be able to have the same distance, the same absolute value. Or they are opposite to each other. This has an opposite value. And now you have two linear equations, then you need to just solve them and find the values for x. So first I'm gonna get rid of this term here to the right side and bring to the left. So now I have 7x here, and this disappears. Equal 20. Now I get rid of the number from the left by adding 16. Now this term is gone, and my 7x is by itself on the left side, and now I have a 36 here. But it's 7x, I just want x. Then I divide by the coefficient, that is 7, on both sides. So now this became 1. Now I have x by itself, and x has to be 36/7. One value possible that would make the distance of this expression equal the distance of this expression. Now this other one, I will apply the distributive property on each term of this expression. 9x minus 16 minus 2x minus 20. Now I do the same process. I'll bring all the variable terms to the left and the constant term to the right. So if it is a negative 2x, I do the opposite, a positive 2x on both sides. Now I have 11x minus 16. These cancel each other, and right side negative 20. Now this term I want to be gone, so then I add 16 on both sides. So this becomes 0, 11x minus negative 4. And now I don't want 11x, I want only x. And then I divide the coefficient 11 on both sides. Here becomes 1. Now I have x, and here negative 4, 11. So the solution set is two numbers. So they are simplified. There is no way to reduce them. So this is satisfied. I want to write as a fraction and use a common to separate the answer as needed. And then I always try to put these in order, smaller. So this is a negative number, common 36/7, but will not matter. Questions 4, 5, and 6 still assess the topics covered in Module 1. And they are related with the linear equation. The linear equation is an equation that contains algebraic expression type polynomial with degree 1. And also assess also about domain and range of functions. Okay, the question number 4 ask you to find an equation of a line. So the equation of a line. So then you know that you be one of these forms here that passes through these 2 points. And they want you to use the function notation. The function notation basically is for you to write in slope-intercept form and then replace the y by the name of the function where the input is an x. Okay, so let's see here. When I have 2 points, I will consider this form here. So I have a point, at least one point, I do have that. I can choose this one or that one. And I need to find the slope. But to find the slope, when I have 2 points, the slope is the inclination of the line. So it's the ratio between the vertical change, that's the y, in relation to the horizontal change. This is the definition of slope, the ratio between vertical change and horizontal change. If I consider this my first point, then this will be x1, y1. And then this will be the second point, x2, y2. I just establish which one is the 1, which one is the 2, and it's your choice which one you want to be the point 1 and the point 2. What is important is the ratio is always between the vertical change with horizontal change. Vertical change. So y2 was in -1, and then it want to go to 8, and then I subtract -1 minus the y1. The horizontal change, I start on 1, and now I went to -2. Be careful with the signs. So here is -9. And this one here is 3, because this 2 here becomes a plus. Then it will be 1 plus 2 is 3. And then I find the slope of the line that passed through this point to be -3. I have a slope and I have a point. I can choose this one or that one. It does not matter. The solution will be the same. I'm going to consider the smaller numbers. So it's my choice. I'm going to use this point here instead of this one. And I will use the point slope form. So I get the y, the variable y, and the y of the point that I chose, -1, equal the slope that I just found, that's -3, and x minus the x of the point that I chose. Now, how I want this in function notation, I have to transform this by algebraic manipulation into another form, the slope-intercept form. So let's isolate the y. First, I have to say that this is y plus 1. Apply the distributive property here, -3x plus 3. Then I add the opposite of 1 in both sides, and I continue here. Then y is by itself because this term disappeared. And now I have -3x plus 2. My y is the name of, I replace with the name of the function. And then so here the problem already gave me the name of the function to be f in function of x, that's the input. And then what is the rule for this function is -3x plus 2. Next one. Here I have a point and I have information. I have an info that will allow me to figure it out, the slope for my line. And then I can write the equation line again using function notation. It already gave you the name of the function here. And so you just have to write in slope-intercept form. Because you have one point in a form to determine the slope, you're gonna use the point-slope form. And then through algebraic manipulation, you rewrite from the point-slope form into slope-intercept. Okay, so when I say that the line passed through this point is perpendicular to this one, I know that there is a very important property when two lines are perpendicular. First of all, I need to write this line that they gave to me in slope-intercept form, because it is not, because there is a 9 in front of the y. So the coefficient of y has to be reduced to 1, and then I divide everything by 9. Then the slope-intercept form for this given line is 1/9 of x minus 2. See that the slope is the coefficient of the variable x. The numerator is 1, the denominator is 9. Then I wrote 1/9. When I say that the equation that I want to write is perpendicular to that, I look into the slope, and my slope, because this is my line that I have to write is perpendicular to this one, the slope will be the opposite reciprocal. So I flip and I change the sign. The positive became negative and 1/9 became 9. So this is the slope of the line that I have to write the equation for. And I have the 2 points. Then I use this point-slope form, y. And I'm going to use, so the y is -6. The slope is -9. And the x is 3. Now I rewrite the equation from point-slope form to slope-intercept. Here becomes a 6, positive. Here I do the distributive, I use the distributive property. And then I solve for y by adding the opposite of this term to make this term disappear. Now y is by itself, minus 9x plus 21. So this is the slope-intercept form of my line that passed through this one and is perpendicular to that one. And then I just replace y by fx that's already written here, and then fx of 9x. So this is the other line that's perpendicular to that passes through this point. The next problem is to find a domain of a rational function. A rational function is a function that contains a rational expression. Rational expression is algebraic expression that is written in a form of a fraction where the numerator is a polynomial and the denominator is another polynomial. So the domain is the input, the possible values for x that I can put in this function to get my output, my y, to create the order pairs for this function. Can I use any variable, x? I have to pay attention because it has to have a restriction. Fractions does not allow a denominator to be 0. So 3x plus 9 cannot be 0. So I have to find what the value of x that makes it 0 to not include that variable in my domain. I cannot feed my function with that variable because it would give me an undefined output. And then I would not be able to have an order pair for that particular function with that variable x. So I solve for x. By adding the opposite and get rid of this, and now 3x equal -9, what implies that x is divided by the coefficient 3 both sides to have the coefficient 1 for x, and then x equal -3. Okay, so when x is -3, I would put -3 here, would give me a 0. So this is a value that cannot happen. So my domain is the variables that I can use as input for this function. Can be any real number except -3. It's any x, such as that x is a real number and x is different of -3. So this is a restriction on the domain of a rational function. Questions 7 and 8 concludes the topic for module 1. Number 7 asks still for the domain. And now instead of a rational function, here I have a radical function. And I have to think about in the real numbers, if I'm using the real numbers, I have a restriction for the radicand. The radicand for square root cannot be negative. It can be 0 or positive number. It means that this expression in the radicand, inside the radical, must be greater or equal 0. Then I find the values possible as an input for this function. Any number that for x that makes x minus 4 greater or equal 0 is valid. So I add 4 positive from both sides to solve for x. Now my x has to be greater or equal 4. And then this is the domain. 4 or numbers greater than 4 are possible, and anything less is not. For example, if I put a 0 here, it would be -4. There is no square root of -4 when we are considering the real number set. And then, so the domain of the function fx, type in interval notation. So they ask very clear how they want. So the domain for this function must be 4 to infinity. Any number from 4 to infinity is a valid input. Another part asks you to complete. So there is 3 parts here. 1, 2, and 3. Complete the table to the right. So here they are asking you to write the order pairs when the input is 4. If I put 4 here, what do I get? I get f of 4 is square root of 4 minus 4. This is 0. What is f of 5? 5 minus 4 is 1. Square root of 1 is 1. F of 13. Square root of 13 minus 4. 13 minus 4 is 9. Square root of 9 is 3. And f of 20 is the square root of 20 minus 4. That is 16. Square root of 16 is 4. And then the order pairs that is created is 4, 0, 5, 1, 13, 3, and 24. Because remember, the definition of the function is a set of order pairs. And I am finding only 4 of those order pairs. But there is an infinite amount of order pairs that when I plot into a coordinate system, it gives a shape. And then here on the second part is asking you to figure it out what shape it would be. So 4, 0, 5, 1, 13, 3, and 24. So when is 4 is 0. And then let's see, here seems to be 2 by 2. And then here cannot be this one because when it's 4, the x is 4, the y is 0. And then can be this one, can be that one or that one. That one will not be possible because I eliminated this immediately because it giving a shape that's that has negative y's. And all my y's are positives. And then so this is eliminate. I don't use this one. And I cannot consider this one because here there is no 4, doesn't start 4 and y 0. Has to start in this point here like that one and that one. Now let's see which one of the two. Okay, satisfy the order pair for 0. Let's see what happened when it's 5, the next one, and it goes to 1. Here, that's good. Then let's see, when it's 13, all the way here, is just 4. This is going too high. So this curve here, the shape of this curve has order pairs that are not those. This one is more like, because the change, as I progress with the x, the change is very little. When it's 20, you're gonna pass here. It doesn't show the 20, but shows the 13. 14, 13 the middle. 13 the middle should be 3. And then is more like it. And then this is the shape of the graph for this function. And each point here is calculated by using the rule for the function and creating the ordered pairs. Number 8. Number 8 is a problem solving. And let's see what this gets us to. There are 2 functions that can be used to describe what? The percent of percent is that, of people 25 years and older who have completed at least high school. So that has a certain amount of study. That has to be at least high school. So those 2 functions give this percent. For both functions, and then here is described the function. One is called fx, that is a linear function. The other is a gx, that is a quadratic function, because degree 2 and here's degree 1. So this is linear and this is quadratic. And saying that the input, the x of those 2 functions here, is the number of years since 2008. And the y of fx or g of x is this percent of people 25 years old completing at least high school. So assume that the trend of gx continues. Find g of 13 and describe in words what this means. Okay, g of 13, so this is the x that has to be used, x, on the g. So let's replace whatever I see x, I replace with 13. 0.009 13 squared plus 0.45 times 13 plus 87.4. I'll use Desmos calculator. I plot this here. Let's see what I get. I plotted this and I got 94.771. 94.771. Now I have to interpret this. What this means? This means that in which year, not year 13, but is the number of years since 2008. So we start in 2008 and 13 years after that, then this gives me the year 2021. In the year 2021, what is the percentage of people 25 years and older that will have completing at least, who have completed at least high school? Will have completed at least high school, Here didn't specify that the people has to be 25 years or older, and the problem says very clear. So it has to be this or that one. But this says less than this percentage. No, this describes exactly the percentage of people who have completed at least high school. So in the year 2021, this amount of people 25 years or older, 24% is a good percentage of people at least completed high school. Questions 9, 10, and 11 assess the topics for Module 2, that is about system of equations. On the question number 9, they ask you to solve the system of equation by using the elimination method. The elimination method wants you to make one of those variables disappear and solve for the other one. If I have negative 3y here, if I multiply the first one by 3, and then I add them together, I will make this term disappear. So let's try first multiplying by 3. 12x plus 3y equal 30. Second one is stay as it is. Now if I add those two equations, I will have 13x, this here disappear, equal 39. Divide both sides by 13. That's the coefficient of the variable x. To make the coefficient 1, I have x equal 3. Once I find the value for x, I get the original system, choose one of the equations and replace x by 3. I'm gonna use the second one, where I see x, I put a 3. And now I solve for y. I will take 3 on both sides, add negative 3. This term disappeared. Now I have negative 3y equals 6. Then, to make the coefficient 1, I divide by negative 3. Now this became 1, and here negative 3. Then my value for y is negative 2. So the final answer, there is one solution, and is the point, is to write in order pair, of course. The point is the point 3, -2. So it means that those two lines, they cross each other in one point, 3, and the point is 3, -2. Next one. They just ask you to solve the system of equation, didn't give you the method, but you just observe. This is solved for x, so I can do substitution. I can substitute the first one into the second one. If I call this one and this the second. So I will start with the 3x minus 9y equals 6. Where I see x, I replace by 3y plus 2. I apply the distributive property here. I have 9y plus 6 minus 9y equals 6. Now combine like terms, these two disappear because one is the opposite of the other. Then I have 6 equals 6. This is always a true statement, regardless the values for x and y. So it means that those two lines, they are overlapping each other. So there is infinite amount of solution. The solution is the line itself. And then the solution set of the system is basically all order pairs that satisfy the equation, one of the equations. They use this one, but I could have used this one because since they are the same, they are equivalent to each other. Number 11. Number 11 is a problem solving involving system of equation. A woman bought some large frames for $15 each and some small frames for $5 each at a closeout sale. If she bought 27 frames for $235, find how many of each type she bought. So from here, you have to extract two equations. The first equation, for example, if I call L for large frames and S for small frames, I know that she bought together 27 frames. Then large plus small equal 27. And I know that she spent $235 buying this amount of large frames for 15 plus this amount by $5. And then so I know that $15 multiplied by the number of large frames plus $5 by the numbers of small frames, this together, if I add those numbers together, this woman, spent $235 by all these frames, 27 frames. They want to know what is the number, how many large ones she bought and how many small she bought. So I can use here any of the two methods that we discussed, elimination or substitution. And then if I multiply this by, I'm going to do elimination, multiply this by -5, because I want to eliminate this S here. You pay attention that you can have a different opinion or position than I have. As long as you have the method and the algebraic manipulation correct, you're gonna get the same answer. Because someone can decide to multiply this by -15 to eliminate this first. Or another person can decide to solve for L or solve for S and then replace on the second one. It does not, the result, as long as your algebraic manipulation is correct, the method that you choose will not make a difference. Okay, so if I multiply my first one by negative 5, I have negative 5L now, negative 5S, and 27 times 5 is negative 135. And the second equation stays as it is, 15L plus 5S equal 235. Then when I add them together, I get one equation that this term goes away, then here becomes 10L equal this negative 135 plus 235 is 100. Then L divide by 10 on both sides, and then is 10. Now that I have the amount of large frames, I replace on the first one, because this has bigger numbers. I replace on the first one, on the original. Then L plus S is 27 frames. If L is 10, how much is S? S has to be 17 to make the total of, and then so your large frame that the woman bought, she bought 10 large frames, and she bought 17 small frames. So I hope that you can quickly read the problem and identify the two equations for the system. Questions 12, 13, and 14 assess one topic still on Module 2 and start the Module 3. The Module 2, we saw factoring. There is factoring of polynomials. And one of them was the difference of perfect cubes. When I rewrite a difference of perfect cubes as the perfect cube of S cubed is S to the third power. And 27 is 3 to the third power. So this is my A and this is my B. I transform this binomial that is a difference of perfect cubes into a factor, a product, into two factors. One is A minus B, and the other is A squared plus AB plus B squared. So this sign matches with this one. And this middle one here is the opposite of that one. So this is what you have to have in mind. So then the first binomial factor is S minus 3. And the second one is S squared plus 3S plus 9. Then that's it. So it is not prime. Prime, remember, a polynomial is prime when cannot be factored at all. So the difference of perfect cubes, you have difference of perfect square and difference of perfect cubes. And you have to know the method of factoring trinomials and using GCF, greatest common factor, to extract, grouping. You have to have all this in mind, because on this question number 13, you're gonna be asked to demonstrate if your knowledge about factoring polynomials. Okay, now 12 and 14, they're the new the module 3 that talks about rational expression, rational functions, rational equations, in division of polynomials, because A rational expression has numerator and denominator as a polynomial. So the question number 12 is asking you to divide two polynomials. So you use long division. I'm gonna write here x squared plus 12x plus 35. And this is divided by another polynomial, x plus 7. First, you look the first term with so first of all, you have to have everything line up in order from degrees, 2, 1, 0, and here the same way. Then you get the first term and try to divide. X2 goes into x how many times? X times. X times x is x squared. But here has the second term, and then I multiply the second term and put here 7x. Then, just like long division, after you multiply back and put here, you're going to subtract. This minus that is 0. So this disappears. 12 minus 7. 12 minus 7 is 5. 5x. And now you put it down everything else. There is just 1/3 term. Now you try again. X goes into 5x. So 5x divided by x is 5 only. Now you multiply 5 times x, 5x. And 5 times 7, 35. And then you subtract to see if there is any left over. This disappears, and 35 minus 35 also disappears. So there is no left over. And now you're done. There is nothing else to put down. When you divide this trinomial, this quadratic trinomial by this binomial, you get the answer x plus 5. Number 14. Number 14, they ask you to, in this case, we're going to subtract. There is a minus here. So you have a rational expression, another expression, then you subtract them. Pay attention that they have different denominator. And then just like a regular fraction, you're going to find the least common denominator between x minus 6 and x minus 6 that multiply x plus 7. The least common denominator has to contain both denominators. The one that contains both is not that one, but is this one. This one contains itself, it contains that one. And then is the smallest one to contain both. And then so the LCD is the whole thing. X minus 6 and x plus 7. Once I know, I have to rewrite both rational expression with the same denominator. The least common denominator now. Let's take care of the second rational expression. Here, the denominator did not change. If it did not change, the numerator does not change. But on the first rational expression, the denominator, initial denominator, was just this part here, and I added this one. If I multiply by that one, altering the initial one, I have to modify the numerator the same way. It was 1, now it has to be 1 multiplied by the one that the denominator multiplied as well. Okay, so now both have same denominator. What I can do is to write both under the same denominator. And then subtract the numerators. The first one is x plus 7. Then distribute 1, doesn't change anything. Minus 25 minus 2x. Because I'm subtracting this whole expression here. Then I put between parentheses. I continue. Still same denominator, x minus 6, x plus 7. Then x plus 7. Now I do the distribution of the negatives. Here's like a -1. So then it's -25 plus 2x. Now is the process of combining like terms. Keeping the same denominator. Then x plus 2x is 3x. Combine like terms. 7 minus 25 is -18. I see that I can factor this because they ask me to simplify my answer. I cannot give the answer like that because this can be simplified, can be factored. And then I found the greatest common factor between 3x and -18, that's the number 3. And then I factor out 3, and I'm left with x on the first term and -6 on the second term. And then the denominator is the same. X minus 6, x plus 7. And I pay attention that now here's multiplying and here's multiplying. If I find same things on the numerator that is on the denominator, I can divide one by the other and make what? 1. So this divide by this is 1. Now I have 3 times 1. Numerator is 3. And denominator is x plus 7. So this is the final rational expression after subtracting those individuals' rational expressions. Question 15, 16, 17, they all deal with module 3. It's still a module 3. We are working with rational equations, expressions, and functions. In this case, so you have to pay attention a lot when you're dealing with the expression, just the expression, or when you're dealing with the equation. The equation you must solve, you must find a x, a value for a known variable that would make that statement a true statement. So equation is a statement. Agora, expression, normally we simplify expression and you do the operations, arithmetic operations with expressions. Okay, number 15. Number 15 is a complex rational expression, or for simple, they just say complex fraction. You have the major fraction, that's the bigger line, but your numerator is an operation with the rational expression in the denominator as well. The first thing that you have to look for the denominators on this complex fraction and find the least common denominator across all denominators that you see. Okay, on the numerator part, you have two denominators, 20x and 25. And on the denominator part, you have one denominator that is the x. That's already here. So the least common denominator between x and 25 is the 25x. Remember that the LCD of an expression is the smallest expression possible that contains both individual expressions. X is inside 25x, and 25 is inside 25x. So this is the LCD. Once you find the LCD, considering all the denominators, you're going to multiply each individual rational expression by this LCD. And then so you multiply on the numerator and on the denominator. The idea is for you to reduce as much as you can this complex fraction. So I'm going to use 25x, multiply each one. Então, vamos ver. 25x multiply x over 25 minus 25x 1 over x. This is on the numerator only. Now denominator, same thing, 25x times 1 minus 25x multiplying 5 over x. Now we start the whole simplification. If I have 25x times x is 25x squared, so this 25 simplify with 25, and then this term becomes x squared. Minus 25x times 1 is 25x, divide by x, so this x and this x, they cancel each other, becomes 1, and now you have only 25. Now denominator, 25x times 1, 25x. E aqui é 25x times 5 divided by x. So this x with this x, because everything is multiplying, then you can simplify x divided by x is 1. And then you have negative 25 times x times 5. The x is gone. I indicated this because I see that there is 25 here and 25 here. Then I can factor this on the denominator. And here is a difference of perfect square. Difference of perfect square, what do I get? X squared minus 5 squared. So this is x plus 5, x minus 5. So this here becomes that factored. And then I write here x plus 5, x minus 5. On the numerator. Denominator. 25 happen on this term and on this term. I'm going to factor the greatest common factor. Find, then becomes, if I factor out 25, I have x minus the 5 that is here. Understand now why I didn't do this multiplication. Now, everything is multiplying. I have a factor here, another one here. They are multiplying each other. I have a number here that's multiplying this term here. And then I see that those two terms cancel each other and it becomes 1. Now, my final answer is x plus 5 on the numerator and 25 on the denominator. There is no more to be reduced. Now this is an equation. The equation we solve, we found, so the variable is y. I'm finding what is the variable, the value for variable y, that when I add 9 over this y plus 1 over 11 is equal to over that y. And then the same thing here. Find the LCD between all denominators. Denominators are y and 11. And then the LCD is 11y. An expression that contains both. Now I multiply each term by 11y. Then I have 11y multiply 9 over y plus 11y multiply 1 over 11 equal 11y 2 over y. This requires some simplification. This is all multiplying, then I can divide y by y to be 1. 11 times 9 is 99. Plus 11 multiply y, that multiply 1. divide by 11. So this 11 with this 11 divide each other is 1. And then now I'm left with y. Now this y and this y cancel, and I have 22. Now I solve for y by adding negative 99 on both sides. Here, the opposite, this term is gone. Now my y is negative 77. So when y is 77, and I replace here and add those two fractions, now became a fraction, 9, so 9, negative 9, 77, plus 1, 11, you'll be 2 over 77. If I check, I would get this answer. The solution set is negative 77. A word problem. This word problem is very much used throughout business. Smith Engineer is in the process of reviewing the salary of the surveyors. During this review, the company found that the experienced surveyor, experienced one, can survey a road bed in 7 hours, and an apprentice surveyor needs 11 hours to survey the same stretch of road. If the two work together, find how long it takes them to complete the job. Okay, pay attention to that. So we have to have a ratio for the experienced surveyor. He surveyed one road bed in 7 hours. So it's a ratio. One road bed, 7 hours. The apprentice one, he surveyed the same road bed, the same stretch of road in 11 hours. One in 11 hours. If they work together, the time that the ratio of the experienced plus the ratio of the surveyor, how long will take? So here is how long you take. The experienced is 7 hours. The apprentice is 11. If they work together, so plus the hours of the experienced plus the hours of the surveyor, how long it take to make that same stretch of road if they work together? The x goes on the denominator because it's the ratio. Here indicates the road bed, how many road beds, and the denominator represents the number of hours to complete that. So here I have LCD. The denominators are 7, 11, and x. And then you'll be 77x. Is the expression that contains each one of them. And then I will multiply each fraction by this denominator, by this LCD, sorry. 77x, that multiply 1/7. 77x, that multiply 1/11. Equal 77x that multiply 1 over x. Here, if I simplify 77 divided by 7, I get 11x. Because times 1 is 11x. Plus, if I divide 77 by 11 is 7. Then I have 7x. And here, this x simplify with this x makes 1, and then I have a 77. 11x plus 7x is 18, né? Command Z. 18x equals 77. I divide by 18 on both sides. Then I get that the x is 77 over 18. What does this x represent? Represent the number of hours when they work together, the experienced and the apprentice surveyor. And this is a weird number. How many hours is that? So if I divide 77 by 18, I think I get 4 here. 8 times 4, 32, 72. Yes. Then left over 5. So it means that in 4 hours and 5/18 of an hour. 5/18 of an hour, 13 minutes, 12 minutes, 4 hours, a little over 4 hours is how long it takes for them working together to survey that same stretch of road. So they ask you to put a simplified fraction. So you can write as a mixed number like that, because then you have understand that how many hours is that, or you can write this fraction here because there is no way to reduce this. This is 7 times 11, and 18 does not contain 11 or 7, so there is no way to simplify, so it's reduced. I just wrote that way for you to have an idea that when they work together, they take less time, 4 hours and a few minutes, 13, 12 minutes. Instead of 7 hours for the experienced one. So the experienced one really wants the apprentice help because it cuts almost 3 hours of his time. And the other one, the apprentice, much more. He wants the experienced help because imagine from 11 hours to do one surveyor, he takes a little over 4 hours. Then can be answered like that. Question 18, 19, 20, still module 3. And now we are starting to going through radical expressions. And the radical expression, we start reviewing some concept of scientific notation and properties of exponents. Because rules of exponent, because the radicals can be expressed as rational exponents. And then the first question, the question number 18 on this page, reviews a little bit the operations with numbers written in scientific notation that is greatly used through all science to express huge numbers and smaller numbers. And here I'm multiplying two numbers that is written in scientific notation. Then this is multiplication. Thanks to the commutative property of multiplication, that I can switch the position of the numbers and did not change the product, I can rewrite this expression as 5 times 2.6 times 10 to the 16th power times 10 to the negative 5 power. When I multiply 2.6 by 5, I get 13. 13, I don't need to put 0.0, not necessary. And I have two powers here with the same base, and I have to know the rules of exponent when it has same base. I keep the base and I add the exponents. So this becomes 11. And then I would immediately give this answer. But then I look, you have to keep using scientific notation. And I'll say, yeah, this is scientific notation. This part is correct, but this is not. This is 13. The number in scientific notation has to be a number between 1 and 10. Less than 10 and cannot have 2 digits, can have only 1 digit to the whole part. And then so it means that 13 has to walk to the left 1 to represent the number 1.3. And if I go to the left once, I'm making this number smaller. And to compensate, I make the power bigger. And then I have 1.3 times 10 to the 12. Going to the left, increase the power of 10. And now the final answer is 1.3. Pay attention to that. You have to keep in scientific notation. Okay, number 19. Number 19 is a radical expression, but is written as a rational exponent. And you have to keep that way because they want the final answer in exponential notation with positive exponents. And they just ask you to multiply. So you have a radical here that is being expressed as a rational exponent that is being multiplied by an expression with two terms. You're going to use the distributive property here, and then you're going to write y half multiplied by y half minus y half multiplied by y 1/4. Here, when you have exponent with same base, you're going to use the same reason that we used here, the same rule. You keep the base and you add the exponents. The second term, the same thing, is the same base. And then you keep the base, one base, and you add the exponents. Half plus half is 1. Y to the power of 1 is y. This is just y. Now, what is half plus 1/4? You can go ahead and use decimals here and then as to represent as a fraction, not as a decimal, right? Okay, but if I know how to get the equivalent with denominator 4 for this one, is multiply 2 on both numerator and denominator. So this is 2/4 plus 1/4, that is 3/4. And then minus y 3/4. And you're gonna leave like that. There is nothing else to do. A subtraction, there is no rule, exponent rule for subtraction of exponents, only multiplication and division. And then this finishes as it is. This is as simplified as possible of the expression when you multiply those exponents, expressions. Okay, rationalize the denominator, number 20. Okay, let very clear. You have a radical on the denominator. This is not incorrect. If you find a problem that finishes like that, this is not incorrect, but it's not elegant. You have to write well, mathematically, things, and we avoid as much as possible radicals and other. You're going to see also complex numbers. We don't leave complex numbers on the denominator. We always try to eliminate them, finding an equivalent fraction that substitutes the original one without having the radical on the denominator. And we do this by conjugate. For example, okay, here I have 1 minus the square root of 3. If I multiply 1 plus the square root of 3 on the numerator and denominator, I am not modifying the initial expression. I'm just finding equivalent expression, multiplying numerator and denominator by the same number. This is a number. And then I have 4 that multiply 1 plus the square root of 3 on the numerator. And my denominator, here this number is the same as this is the same as that, and there is a difference of sign. So these are two factors that do the difference of perfect square. The square of the first minus What is the square of square root of 3? If I write this as a rational exponent, it will be 2 over 2. This is 1, and then this is 3. So when you square or multiply the root by itself, the root go away and stay just the radicand. Now I can have, I'm still not distributing this because I see that I can have a -2 on the denominator, and then I can simplify those two because here there is a multiplication here. And then I will have -2. 4 divided by -2 is -2. 1 plus the square root of 3. This can be your final answer, or if you want to distribute and write like that. See, or that way. To avoid, so it's not necessary the distribution, and then I will go for the less work without the distribution. Question 21, 22, and 30. I jump to 30 because those 3 questions are concluding the assessment for module 3. It's about the radical. And we finished that module discussing the complex number because we start to see problems with radicals when radicals of even index, like square roots, fourth root of negative numbers is not a real number, but can be treated as a complex number. And then we're gonna discuss the 30, that's the last question, but this question was part of our topics on module 3. Okay, here we have an equation. We see because it has equal sign, has the left side, right side, and this is a radical equation. And they ask you to solve. So I have to find what is the value for this unknown number that when I replace here and replace here makes this root equal this root. Okay, to solve this, I must square both sides of my equation to make the root disappear. Not as magic, but through properties and algebraic manipulation, I know that when I multiply a root by itself, we just did this, square root of 3 times the square root of 3. You can put both under the same root because both is square, and then this becomes 9, and then this is 3. Or you can use the property of exponent, the square of a root, and you use as rational exponent, you write 3, the power, and the index. And then 2 divided by 2 is 1, and this is 3. You can use, so this manipulation, this algebraic manipulation, exists properties behind it that justify why the radicals disappear when I square them. And then now I don't deal with the squares anymore and just the radicands. So I have x plus 4 equal 2x minus 1. By squaring both sides, I didn't modify the statement. I just found an equivalent statement that still hold truth. Now this is linear equation, and I know how to solve. So I will first bring x to the left side and the number to the right side. Okay, by doing that, I add the opposite of 4 on both sides. This term no longer exists. Then I have x on the left and 2x minus 5. Now I add the opposite of 2x both sides to get rid of x on the right side. Now I have negative x equal negative 5. Multiply both sides by negative 1 to make x positive. And then I know that x is 5. And for me, I can verify this very quickly. What is 5 plus 4? 9. Square root of 9 is 3. So the left side is 3. Let's see if the right side gives me whole 3 as well. 2 times 5, 10. 10 minus 1, 9. Square root of 9, 3. Okay, so I found a value for x that make those two radicals equal. And then 5. There is a solution. Solution is 5. Problem solved. There is a formula, v equals square root of 2gh, that gives the velocity in feet per second of an object after it falls h feet accelerated by the gravity in feet per second squared. If g is approximately 32 feet per second squared, find how far an object has fallen if the velocity is 48 feet per second. So he gave you a formula to find the velocity when you have the gravity and the height where this object fall from. And gave me some values. The gravity that I'll be using is 32 feet second squared. This is the gravity. The velocity of this object is 48 feet per second. And they want to know how far this object is falling from. So they want the h from this formula. I can first manipulate this formula, literally, a literal formula, to isolate the h, because it's the h that I want. So I start with the formula v square root of 2gh. If I square both sides, I get rid of the root, right? And then I would have v velocity squared is 2gh. How do I have h by itself? If everything is multiplying, I divide. This represents the coefficient for h. Then I divide by 2h on both sides. G on both sides. And then this, it becomes 1. And now I know to find the height, I need to square the velocity and then divide by 2 times the gravity. Velocity is 48, and then it's 48 squared. And here is 2 times 32. And again, here you go to decimals and you put this expression, this numerical expression, and let the decimals find the value for you. So I represent here for you. So the squares, you have to come and make use of the calculator here. 48 squared divided by 2 times 32. Pay attention if your expression has to look exactly like the other one. And the value that obtained was the number 36. And what is this 36 means? The object has fallen 36 what? Cubic feet, square feet, or just feet? Feet, because it's the length and the height that the object falls. The number 30, you are doing division of two complex numbers. And again, I have mentioned that could live like that, but they want you to simplify your answer. Solve this division, simplify. So to do division of complex numbers, we use the concept of the conjugate and use the conjugate property. And you have to know the conjugate when it's just the complex number with the opposite sign here for the imaginary part. And I multiply both numerator and denominator by the same number to not alter the initial fraction, but to find the equivalent to 1. And then here I will have 1 plus 5y that multiply 1 minus y. And the numerator, you always have the square of the real part, the a. The square of the a, 1 times 1 is 1, and plus the square of the b. What is the b in front of the imaginary? Is 1, right? And then 1 times 1 is 1. So this is 2. The denominator transforming the number 2. So you have to know this property. If you have a plus bi multiplied by its conjugate, you'll be the square of the a plus the square of the b. The real part and the constant of the imaginary part. Here I have to apply the distributive property. You'll be 1 minus I plus 5I, then plus 5. The second part here, I'm gonna solve here on this side. 5I times I is 5I squared. I squared is negative 1, and then I have negative 5. This multiplication is negative 5, but I have a negative on the outside. 2 negatives makes a positive, then becomes a 5. And your denominator is still 2. Now you combine like terms, real part with real part, imaginary part with imaginary part. The real part here is 1 and 5, and then gives me 6. And the imaginary part is negative 1i plus 5i. So this is 4i. And all this divide by 2. And I have to write as the real part and the imaginary part. So then I will write the real part is 6 over 2. And the imaginary part is 4 over 2i. And I can simplify. 6 divided by 2 is 3. And 4 divided by 2 is 2. My final answer for this division of two complex numbers is the complex number 3 plus 2i. Questions 23 forward is related with the last module, module 4. Is solving quadratic equations and graphing and problem solving with involving quadratic equation. The question 23 asks you to solve this equation. On the left side, so the equation has the equal sign, the left side you see a polynomial. In fact, it's a trinomial because it has 3 terms and it is degree 2. So this is a quadratic equation because it's comparing, so a polynomial with degree 2 is called quadratic polynomial. This quadratic equation is being compared with 0. So they tell me to solve. I will try. The first step is to see if I can factor. There is 3 methods that were taught in this course, and I'll try the first one, that's the factoring. Factoring a trinomial with lead coefficient 1. the product, so using the X game. And I am inclined to do that because I already see a number that multiplied by 2 is 24 and the distance is 2. The number is 6 and 4. 6 times 4 is 24 and the distance between 6 and 4 is 2. And then I'm inclined to try the factoring. So the result of the product has to be negative 24 and the sum has to be negative 2. The numbers is 6 and 4. Now I have to take care of this sign. The product is negative and the sum is negative. One of the two must be negative for the product to be negative. And which one? It be the bigger one, because when I add, the result is negative. So I can rewrite the initial trinomial as a product of x minus 6 and x plus 4. And this must be 0. Now you apply another property. So we are doing manipulation and transform the trinomial into a factor of 2 simpler polynomials. This is a binomial degree 1, a binomial degree 1. And now I use another property, the property of multiplication by 0. If there is two things multiplying each other and the result is 0, it's because one of them must be 0. And then now is the time that I break it down for, okay, x minus 6 must be 0 or x plus 4 must be 0. And then here I get x equals 6 and here I get x equal negative 4. It means that if you plug in back 6 here and to the final calculation, x squared minus 2 times 6 squared minus 2 times 6 minus 24, it will be 0. And with negative 4 the same way. So the solution, there is two solutions for this quadratic equation. The second one, they specify very clearly, the question 24, very clear for you to apply the square root property to solve the equation. So you have to understand that if I have a number squared and say that is b, it means that the number is the square root of b, positive or negative 1. So my a here is 2x minus 1, and my b is the 25. If I apply the property, it says, so this, it says that 2x minus 1 is equal square root of 25 positive or the negative 1. A typical example, a simple example, so if I say that x squared equal 9, what is the value for x? X must be the square root of 9 with the positive and negative sign. That is, x must be positive 3 or negative 3. That will make this true. Okay, now that I have these, I have in fact two equations. One is 2x minus 1 comparing with 5. And the other one is 2x minus 1 equal negative 5. So this value here must be 5 or negative 5 for this equation to be true. Then what must be x? Now I solve for x. X here must be 3. And here the x must be negative 2. If I can do a quick check. replacing those values on the initial equation. 2 times 3 minus 1 is squared. 2 times 3 is 6. 6 minus 1 is 5. And this is 5 squared. And this is 25. True for the equation. This is what I said that the statement says. The second one, 2 minus 2 minus 1, and this must be squared. So I'm just plugging in the value for x here and trying to solve. 2 times negative 2 is negative 4, minus 1, negative 5, and this is squared is 25. So you found the correct answer. That's letter D. So here, and here it's telling to use the quadratic form. First, I look this equation and I see that for me to use the quadratic form, my expression, my polynomial must be in standard form. To be in standard form, I have to start with, I have to move this term to the left side. Now I know the values for A, that is the coefficient of the square term, 8. The B is the coefficient of the degree 1 term, negative 2. And my C is the value for the constant on this trinomial. And with that, I have also written here, I'm going to write the quadratic form. Minus b, so x is minus b plus or minus square root b squared minus 4ac divided by 2e. And let very clear here that this radicand, I use the delta symbol, represent the discriminant of this function. So because based on the value that I have inside of the radicand, I can determine what type of solution that I have. When the discriminant is 0, I have one solution. If the discriminant is equals 0, if it is greater than 0, I have two solutions in the real, as a real number. And if it's negative, I have also two solutions, but this is complex numbers. And here is real number. And here also real number. So I start by determining the value for the radicand or the discriminant, or that I use the delta. So let's get b squared minus 4ac and see what value this would be. So b is negative 2. Negative 2 is squared minus 4 times 8 times negative 7. So this, now I have number negative 2 squared is 4. And I will have the value for this multiply 8 times 4 is 32, then times 7 is the number I add, because two negatives makes a positive. 4 times 8, 32. 32 times 7 is 224. So you're going to plug in on decimals and find this number. And then the final value for delta is 228. So I know from here already that I will have two solutions that are real numbers. And now I start with the formula, negative b plus or minus the square root of 228 that I just found. And all this over 2a. The b is negative 2. So then minus 2 plus or minus. And then now the 228, I will factor because I know that this is not a perfect square, but I want to see if I can extract something out of this square root of 228. What I do is the 3 to see. So this I can divide by 2, and then I have 1, 1, 4. I can divide by 2 again, and then when I divide this by 2, I have 5, 7. 5, 7 is prime, but I have two 2's. So it means that I will extract 1, 2 out, but the 57 stays inside of the square, because this can be written as 4 times 57. Then is a multiplication here. It means that the 2 goes out. Square root of 4 is 2, and then stay 57 inside. And all this is divided by the number 2 times 8. Here becomes 2 plus minus the square root of 57 and 2 times 8. I'm going to leave this indicated because I know that I will be able to simplify the 2 with this 2 and this 2 with this 2. And then the 2 will not have anymore. And then I will have two answers. The first x will be 1 plus the square root of 57 divided by 8. And the other one, the second x, will be with the negative 1 minus the square root of 57 divided by 8. And these are the two answers because they want you to answer including any radical. It's not to plug in on the calculator and extract a decimal number. They want you to reduce the max that you can, and then you're going to enter your two answers by common. So the first one is 1 plus square root of 57 divided by 8. And the other one is 1 minus the square root of 57 divided by 8. Here I'm going to demonstrate how to solve the question 26 and 29. So I skip a few because both are word problems. They are problem solved using quadratic equations. The first one talks about a waterfall that has a height of 1,700 feet. And then a pebble is thrown upward from the top of the falls with an initial velocity of 12 feet per second. The height of the pebble, h, in feet after 30 seconds is given by this equation, and is a quadratic equation. How long after the pebble is thrown will hit the ground? So if I have a picture here, so I have a waterfall, and then there is a little pebble that is thrown up with the initial velocity. And eventually, because of the gravity, this pebble is gonna come back down. And there is an equation that as the time goes by, I can determine the height of the pebble. And this equation is a quadratic equation. And the question is, how long after the pebble is thrown will it hit the ground? And then, so how long? So they want to know the t, the time when the height of this pebble hit the ground. So it's 0. There is no height at all. So those are the two things that you have to extract here. What they want, that's the time. And to hit the ground, it means that the height, so if this is a formula that gives the height of the pebble, to hit the ground, there is no height, and then it means that the height is 0. So if I plug in this here, what they are asking me to do is to solve for t. My variable is not x, it's t in this case for time. 1700. And this must be 0. And then from only reading this and determine who is t, what I want, and what is the value for h, I have a quadratic equation that's compared with 0. And immediately here I can extract the a. I will use the quadratic formula to solve this. And in this case, you're going to plug in directly to the calculator because they want as a decimal to the nearest tenth to see how many seconds with the nearest tenth. And then a is negative 16. The b is 12. And the c is 1700. And then you're gonna minus b, use the formula, plus or minus the square root of b squared minus 40c, and all these divide by 2a. So this is how you're going to determine the two t's or one t. And so you use decimals, and here you plug the values for a, that's negative 16, the b, minus b, and I did one for the plus, one for the minus, and then b squared minus 4a and the c. Be careful how you do this. You have to use the calculator, the symbols for the calculator, and determine this. And then I found that one answer for t is negative and the other is positive. Of course, I'm going to consider the positive one. So I ignore, even though it gives me two solutions, I ignore one for the negative because I have to interpret the answer after the fact. And here is to round to the nearest tenth. So it's 10 point, and then 8 make 6 turn into 7. And then the answer is 10 point. 10.7 seconds. Because the time is given not in feet per second, but is seconds. So you have to know the unit. Okay. Number 29, let's see. If a projectile is fired straight upward from the ground with an initial speed of 120 feet per second, very similar how here we're talking about a pebble, here we're talking about a projectile. Then its height in feet after t seconds is given by this formula. Find the maximum height of the projectile. So let's do, so if you have here the floor, this projectile is sent up, and then eventually get a certain height and has to return because of the gravity. You want to know what is this height here. So pay attention. When this parabola will be up, downward, and when it's downward, what is the maximum point maximum? This is the vertex. The vertex, when the parabola is downward, represents the maximum value possible for that parabola. And then so we have to find this vertex here to determine what is the height of the projectile. Okay, from the formula, from the function height, function of t, negative 16 t squared plus 128t. I have the value for A, that is negative 16. The value for B, that's 128. And the value for C, that is 0. There is no constant on this one. And then for me to find the x, the t, because now my variable is not x, it's t. The t for this vertex here, we have seen that t for the vertex, we have seen that's negative b divided by 2a. Negative b is negative 128. And 2 times negative 16. So this negative divided by a negative becomes a positive. So this will be negative 128, and this will be negative 32, and this divided by that is the number 4. So in 4 seconds, after 4 seconds, it hit the highest, the highest peak for this project. And then, then I go back to the original function, and I want to find what is the height then on these 4 seconds, after 4 seconds, because they don't want how long you take to get to the maximum height. They want to know what is the maximum height. And then so I know that it will take 4 seconds to reach this maximum height because it's the value of the vertex, the x of the vertex. Now I found the t. I plug in to find what is the output when the time is 4. Then negative 16 4 is squared plus 128 times 4. So this will give you the number 256. And we are talking about units. So the speed is feet per second, the height is in feet. And then the answer is 256. And the choice that you make, because probably be a drop-down menu that you're gonna choose the unit of feet. Questions 27, 28. Those are the last questions that is related with graphing. And the idea, so let's see, the number 27, question 27. Sketch the graph of the quadratic function in the axis of symmetry. State the vertex and give the equation for the axis of symmetry. So these are a quadratic equation that is written in vertex form. So from here, from the function, you don't need to do any calculation, and you're gonna extract the vertex. Here is your x for the vertex, and here is the y of the vertex. And then the vertex in order pair is the point 3, 3. The axis of symmetry is the vertical line that split your quadratic, your parabola in two congruent sides and is always going through the x of the vertex. And then a vertical line is written x equal something, and then this something is the x of the vertex. Now that you have those two information, so you didn't have to do any calculation whatsoever so far. You just have to understand how, so you go back and watch to understand very well that this form, the vertex form, give you all this information for you. Now I will mark. So I know that this parabola will be, the vertex is 3 and 3, this point here. And the parabola is upward because there is no negative sign here. There is a positive sign, so it means that you'll be upward. And then you find a few values that you can use to plug another value. For example, okay, when x is 0. When x is 0 here, what do you have? You have the 12, right? When x is 0. Then the f of 0, x equals 0. F of 0 is 0, negative 3 squared plus 3. And this is the number 12, because this is 9, 9 plus 3, 12. So when x is 0, the y is 12, or the f of 0 is 12. And now if I get number 6, also will be 12. Because 3 to the left, now I have my vertex is on 3. And then I got the 0, so I took away from my x 3 points. And now I add 3 points, so 3 to find the other side, and it will be 12 as well. Then 0, not a 0, it will be 6 minus 3 squared plus 3. And this is also 12. And then when it's 6, 4, 5, 6 is 12. And then here I am apt to draw my, and for you, it'll be much easier because you have a map. So you just need to find the vertex and a point, and then they plot for you a parabola. And here you're gonna mark the axis of symmetry. That's a vertical line. This is from the chapter, from the module 1, that you have to know how to write an equation for a vertical line. An equation for a vertical line starts with x equal a number, the number where the x crosses the x-axis, and then it's on 3. That is the vertex, the x for the vertex of the parabola. And the purpose of this imaginary line, vertical line, is to show that this is split the parabola in two congruent pieces. This right side is congruent, is the same in form and shape as this one here. And then that's it. Probably they will ask you to be there is solid curve, so you have to use a solid curve to graph the function, and a dashed line to graph the axis of symmetry. Pay attention to that, because if you put both solid or both dashed, you will not get the full point for it. Okay, last one. Here, I don't have a formula, the form, not a vertex form, but is in standard form. And they ask you to find only the vertex for this graph. And then when you have a standard form, you're gonna use negative b divided by 2a to find the x of the vertex. And after you find the x of the vertex, you plug in this value for x on the function, and then you find the y of the vertex. And with those two, you're gonna have the vertex x, the point xy for the vertex when it's a standard form. And then let's start. So here, identify a to be 3, b to be 6, and c to be negative 6. And then the x for the vertex is negative 6, because b is 6 and now became negative 6. 2 times 3. So the vertex, the x of the vertex is negative 1. And now we're gonna plug in the negative 1 on the function formula to obtain the y of the vertex. Negative 1 is squared plus 6 times negative 1 minus 6. Be very neat, organized, that you don't get things messed up. Here becomes positive and then becomes 3. Here becomes negative and then it's negative 6. And here another negative 6. Then the value for the function when the x of the vertex is negative 1 is the number negative 9. And then I have to write in order pair. So this represents your y of the vertex. Is the function, the value of the function when the x is negative 1. So then this is negative 1 and negative 9.